Hello friends, welcome to my channel. Let's have a look at the daily challenge problem, that is problem 987, vertical order traversal of a binary tree. So in this video, we're going to share a solution based on binary tree traversal, as the problem title suggested. So first, we're going to read through the statement of the problem, and then do some simple analysis, and finally we share the simple code. First, let's look at the statement. So given the root of a binary tree, calculate the vertical order traversal of the binary tree. So here, for each node at position row and column, its left and right children will be at positions row plus 1, column minus 1, and row plus 1, column plus 1, respectively. So the root of the tree is at 0, 0. So here, actually, the positions are relative. So this sentence actually is not very necessary. The reason is that once we fixed an indexing R0, C0 for the root, then the subtrees and the corresponding nodes are actually determined in the sense of indexing. So the vertical order traversal of a binary tree is a list of top to bottom orderings for each column index, starting from the leftmost column and ending on the rightmost column. There might be multiple nodes in the same row and the same column. In such a case, so sort these nodes by their values. So we are required to return the vertical order traversal of the binary tree. So that's the main statement of the problem. So here are three examples. So let's first look at the example 1. So this example 1 is a very simple case. So if we use 0, 0 as the indexing for the root node, and then the problem, or in the example, it marks the indexing for each of the nodes. So there are 4 different column indexing involved: -1, 0, 1, and 2. So corresponding to -1, so we have none, and corresponding to column 0, so we have 3 and 15. So similarly, you can check for column index 1 and column index 2. So this is example 1. So similarly, we can look at example 2. So in example 2, there are 5 distinct column indices involved, from -2 to +2. In particular, for column index 0, so we have values 1 and 5 and 6. So this 5 and 6 actually have the same row and column indexing. So we need to sort them from small to large. So we have 1, 5, and 6. So that's the return. And in example 3, so the tree slightly changed in structure. And so in column index 0, so we have 1, 6, and 5. And 6, 5 have the same row and column indexing, because we need to do sorting. So the return corresponding to column indexing 0 is still 1, 5, 6. So this is example 3. So with that said, let's also look at the constraints. First, the number of nodes in the tree is in the range given by the closed interval 1 and 1000. So notice that this gives us that the tree is not null. Secondly, the tree size is bounded above by 1000 in the sense of node counting. And secondly, the value of the nodes are bounded in between 0 and 1000. So with that said, we finished the statement and the assumptions on this problem. So here, let's look at the method and idea. So this problem is marked hard by Leetcode. Actually, this problem is rather straightforward. So we're going to use traversal for this problem. So the idea is simple. So we do traversal of the binary tree. At the same time, when we do the traversal, we are going to retrieve the node with the indexing information. So we are going to use a two-dimensional indexing. So see, we are going to use two numbers, RC, right? So here, notice that the positions of node and children are actually relative. For example, if a node has a relative position given by R0, C0, then its left child indexing is R0 plus 1 and C0 minus 1. So minus 1 means left. So for the right child indexing is nothing but R0 plus 1 and C0 plus 1 2. So plus 1 means right. So here is an example walkthrough. So for example 1, so we can actually find the corresponding information according to each of the distinct column indices, and then we store the node value and the corresponding indexing. So for column indexing 0, so we get 3, 15, and for column index 1, so we get 20, and for column index 2, we get 7, and for column negative 1, so we get 9. So this is the corresponding column index and the corresponding node values with that column indexing. So this is corresponding to example 1. So once we actually get the corresponding value for each of the column indexing, so we can actually do some sorting according to the row from small to large and the value from small to large, so to prepare the return. So this is basically the overall thought. So notice that there are many ways to do binary tree traversal. For example, according to the order we visited the root, the left subtree, and the right subtree. So we have a pre-order traversal, in-order traversal, post-order traversal. Or we can do breadth first search corresponding to the level order traversals. Or as the problem here, so we can call this traversal here vertical order traversal. So there are also some other techniques like Morris traversal. It's also good to be aware of or know. So with that said, so here in this video we're going to share a solution or traversal based on a iterative format. So the reason is that we want to expose the details more clearly. So for this, first I'm going to do a traversal. For the traversal, we're going to track the corresponding indexing information. So for this, I'm going to initialize a dictionary called aux. You can understand it as auxiliary. So we're going to use a dictionary. Let's call it default dictionary. So we're going to use a list as container. So you can actually also use vanilla dictionary. So this way of writing might save one line code, but it just depends on our choice. And then we're going to initialize a container. So the container will store the root and the indexing. So here, let's use 0, 0 as in the problem statement, but it's not necessary. You can pick any R and C. So here, what we store is node and RC, the indexing. So then we are ready to do the traversal. So here, well, the container is not empty. So we can get the node and the indexing information. That is container pop. Then what we're going to do is that, so the corresponding node has an indexing C in column. So we're going to add this information to the dictionary. So we're going to append. So let's use a tuple. So node value. So R and C. So actually we do not need to store C, but let's write in with some redundancy. So this is the store information step. Then we are going to check the children of the node. So if node left, then what we're going to do is that we're going to put the information into the container. So this node left. So the relative indexing will be R plus 1 and C minus 1. C minus 1 because we are considering the left subtree. And then we copy this this block and check the right subtree. Let's change this left to right, and do not forget to change the C minus 1 to be C plus 1, as we are considering the right subtree. So that's basically about it. So this way, after we end the while loop, we get all the information stored in the aux dictionary. So the next step is basically prepare the return. So there are many ways to do this because all the information is stored in the aux dictionary. So let's do this here. So we're going to initialize a result. So the final state of this variable is what we want to return. And then we're going to prepare the corresponding array or list for each distinct column indexing from small to large. So for this, I'm going to use a for loop for k in sorted aux keys. So after sort, the keys will be from small to large. And then we're going to get a temporary variable. So we're going to make it sorted. So this corresponding to the value. So what we're going to do is to sort this according to the row indexing. So that is x1, right? The second one. And then if there are ties, so we're going to sort according to the value itself. So this is the temporary variable. And then once we get this information, so we're going to put the corresponding node values to the result. So we're going to append the result with a list. So let's call it item 0 for item in temp. The first component corresponds to the node value, right? So yeah, with that said, I guess that's about it. So we can actually return the result. So this consists of a full solution to this problem. So let's first do a special case check, I guess. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So with that finished, I guess that's about it for this video. So basically, we write this code with two steps. First, we do a traversal, and then prepare the return. The logic is actually clear, and the code is actually short. So with that said, that's all. Thank you very much.